Hey all. Welcome to the fourth episode of Space Telescopes, your single point of contact for tweets and observations from space observatories. This section contains core images and videos from this episode, dedicated for people in a hurry. Others just chill out and skip this section. NASA Universe. The supernova responsible for the Crab Nebula was observed in 1054 AD and catalogued as a guest star by Chinese astronomers. Recently, we have been able to map the changes in the cloud of debris left behind by this explosion. This Hubble image of Eagle Nebula is one of the most recognizable images. But what is a nebula? Follow along this week as we explore these majestic cosmic structures. Nebulae are giant clouds of gas and dust in space. They are most commonly associated with two parts of the life cycle of stars. They can be nurseries, forming baby stars in their clouds, and/or gas and dust that are blown outward during the death of a star. As great as nebulae look, how do we get these terrific views of them? With the help of some missions, like the now-retired Spitzer Space Telescope, Hubble, and soon James Webb, scientists are able to study nebulae in many different wavelengths. Many people consider nebulae to be some of the most beautiful objects in the universe. But what are they exactly, and how did they come to be? Check out the Tumblr link in description. Not all nebulae are alike, but their different appearances tell us what's happening around them. Since not all nebulae emit light of their own, there are different ways that the clouds of gas and dust reveal themselves in. One of the ways we are able to see nebulae is through interactions between stars and the clouds of gas. These stars are heating up the gas, whose chemicals respond by glowing in different colors. Think of it like a neon sign. Many nebulae scatter the light of the stars, hiding in or near them. This is like seeing a street lamp illuminate the fog around it. Sometimes nebulae are so thick with dust that the visible light from young stars within them cannot shine through. This cloud comes from a star, expelling its outer layers, something our sun will do billions of years from now. Stars recycle. After millions or billions of years fusing chemical elements in their cores, stars cast off this material, which finds its way into new objects. Planetary nebula like this one forms when aging sun-like stars expel their atmospheres. Missions like now-retired Spitzer Space Telescope, Hubble, Chandra and soon, James Webb, help scientists see the different elements that oftentimes light up nebulae. Hubble observes the cosmos in multiple wavelengths of light. They range from ultraviolet, visible, and near-infrared. Hubble peered at the iconic Eagle Nebula in visible and infrared light, revealing these grand spires of dust and countless stars within and around them. Chandra studies the universe in X-ray light. The spacecraft is helping scientists see features within nebulae that might otherwise be hidden by gas and dust when viewed in longer wavelengths. In the Crab Nebula, Chandra sees high-energy X-rays from the central source. Webb will observe the universe in infrared light. With it, scientists will peer into clouds of dust and gas to study stars and planetary systems that are forming. Spitzer studied the cosmos in infrared light before retiring on January 2020. Spitzer revealed unknown materials hiding in nebulae, like oddly shaped molecules and cosmic materials, similar to soot found in the California Nebula, pictured here. Katherine Johnson was born on the 26th of August 1918. She was a NASA mathematician, known for calculating paths for crewed missions orbiting Earth and landing on the Moon. Also, on the same day in 2009, Hubble stared at a tiny, seemingly empty spot in the sky and found thousands of galaxies, some of which formed over 13 billion years ago. Find out what Hubble saw on your special day from the link in description. Studying nebulae helps us better understand how they formed and how they work, and even gives insight into the life cycle of our own star, our Sun. Our Sun got its start in a stellar nursery. Gas and dust in a nebula, clumped together, thanks to gravity, and eventually form a baby star. It can take upwards of 1 million years for a star to be born. After billions of years of fusing hydrogen into helium, our Sun will eventually puff into a huge red giant star, before it leaves behind a beautiful planetary nebula, along with a small, dense object called a white dwarf, which will cool down slowly. Since the Sun lives so much longer than us, scientists can't observe its life cycle, but they can study tons of other stars and nebulae at different phases, and draw conclusions about where our Sun came from, and where it's headed. The Crab Nebula was created by a supernova, nearly 1,000 years ago, but continues to be a scientific puzzle. As the Earth blocks its view, Fermi has measured changes in the nebula and seen its brightness slowly vary over the last decade. Hubble ESA. This picture of the week shows an open cluster, known as NGC 2164, which was first discovered in 1826 by a Scottish astronomer named James Dunlop. ESA Hubble Flashback. Astronomers observed this supernova remnant to search for a potential stellar survivor of the explosion. Do you have an Instagram account? Our filter will place you against a starry background and show the Hubble spacecraft orbiting you. Time to try it. Hubble Space Telescope. A smaller galaxy crashed through the center of NGC 922, causing gravitational ripples that disrupted the clouds of gas and triggered star formation. New stars illuminate hydrogen to create bright pink nebulae. National Dog Day celebrations for Hubble meme, an appreciation post for all that Canis Major, the great dog, has to offer, like Nebula Sharpless 230. It's full of stars. Some 25 million stars can be seen in this Hubble panorama of Messier 33. No wonder astronomers are going to target it with Hubble to learn about star formation. Hubble, NASA. Have questions about the Hubble Space Telescope? Reply with your questions for a Q&A. Hubble has shown us that the cosmos is more colorful and often stranger than we ever could have imagined. The Q&A thread will take a separate video. If you find time, the link to the thread is in description. Spiral galaxy NGC 3982 dazzles in this Hubble classic view. The galaxy's arms are lined with pink star-forming regions of glowing hydrogen, blue newborn star clusters, and dark dust lanes that provide the raw material for future generations of stars. Happy National Dog Day! This Hubble image captures the brightest star in our sky, the dog star, Sirius. Try to find its white dwarf companion Sirius B in the lower left. Sirius is 8.6 light-years away, the fifth closest star system known. NASA Exoplanets. 4,472. That's how many planets beyond our solar system we know of, so far. These worlds are many light-years away, and most seem unlike those in our own planetary neighborhood. All science starts with a question. Why? How? Wait, what? We know you have got questions too. We have got answers. Check out some of our big questions and answers. Link in description. We launched the Spitzer Space Telescope on the 25th of August 2003. The spacecraft taught us about stars, galaxies and planets well beyond our own solar system. You might even consider it a space superhero. A glimpse into the video released by NASA last year. Full video link in description.
Many years later, having revealed a whole side of the universe we would not have seen without it, NASA's Infrared Great Observatory retired. But because of their success, Spitzer and its Space Telescope super friends would not be the last of the great observatories Soon, another powerful infrared observer would follow, taking up the legacy of those that came before.
It takes a lot of work to get a spacecraft ready for launch. And James Webb Space Telescope is at one of its final steps. The team has shifted from demonstrating it can survive launch and work in orbit, to making sure it will safely arrive at launch pad. Chandra Observatory. Cavities in multi-million-degree gas show the central black hole in NGC 5813 has erupted multiple times over 50 million years. Jets generate shock waves that push the gas outward and create huge holes, like an air bubble rising to the surface in water. Can you believe it's been 15 years since Pluto was reclassified as a dwarf planet? In 2006, the International Astronomical Union, IAU, redefined what a planet is in our solar system. A planet is a celestial body that is in orbit around Sun, has sufficient mass for its self-gravity to overcome rigid body forces, so that it assumes a hydrostatic equilibrium, nearly round shape, and has cleared the neighborhood around its orbit. Pluto hasn't cleared the third criterion. Sorry, Pluto. The intense gravity of a supermassive black hole can be tapped to produce immense power in the form of jets of particles moving at millions of miles per hour. This image shows it happening in 4C plus 2930, a galaxy about 850 million light-years away. Spiral galaxies IC 2163 and NGC 2207 are merging about 130 million light-years from Earth, in Canis Major, the greater dawg. Wonder if they sniffed each other first? Happy National Dog Day. This X-ray image of supernova remnant G292.0 plus 1.8 shows a rapidly expanding intricate debris field that contains large amounts of oxygen, yellow and orange, and other elements such as magnesium, green, and silicon and sulfur, blue, that were forged in the star before it exploded. Athena X-ray Observatory. Athena followers, are you ready to test your creativity? Participate in the first Athena Memes Contest to celebrate 2021 European Researchers' Night. The deadline to send your memes is the 20th of September. Webb Telescope, NASA. Testing complete. James Webb Space Telescope has completed testing at Northrop Grumman facility, demonstrating that it can survive its journey into space. Engineers are now preparing to ship Webb to its launch site of Kourou, French Guiana. This video shows the process by which Webb is folded into its launch configuration. On the 25th of August 18 years ago, the Spitzer Space Telescope launched into space and began its mission to reveal the infrared universe to the world. This image of Messier 81 was among the first released after Spitzer's launch. Space Telescope Science Institute. Every human's fingerprint is unique. Similarly, every element's absorption and emission spectrum are unique. Learn more about why different elements have different spectral patterns, in Part 4 of Spectroscopy 101. What's 10 times brighter than the Sun, rotates hundreds of times faster than Earth, and has a temperature of 8,000 degrees Celsius? It's Altair, the brightest star in the constellation Aquila. But how do we know what we know? Check the link in description. Finally, thanks to these magnificent engineering marvels we see beyond our reaches and behind in time. And thanks to you friends, for your patience. Check the video description for links.